Have you ever wondered how crude oil, that thick black liquid, transforms into petrol, diesel, jet fuel, and LPG? It's a complex process that underpins much of our modern transportation and energy infrastructure. Today, we'll explore crude oil refineries, the industrial giants fueling our modern life, seeing how engineers convert raw oil into valuable fuel step by step. This journey takes us from the oil field, through pipelines, to the refinery, and finally to your local petrol pump. Crude oil is a naturally occurring mixture of hydrocarbons, along with sulfur, nitrogen, oxygen, and trace metals. These hydrocarbons are molecules primarily made of hydrogen and carbon, forming the basis of all petroleum products. Its composition varies, making it light or heavy, sweet or sour, but this raw material is useless until refined, which is where the process truly begins. This refining process is essential to unlock its potential as fuels, lubricants, and raw materials for plastics. The first crucial step is fractional distillation, where crude oil is heated to about 400 degrees Celsius in a furnace and then sent to a tall distillation tower. This initial heating is critical to vaporize the various components of the crude oil. Inside, different hydrocarbon fractions condense at varying levels: LPG and gasoline at the top, kerosene and diesel in the middle, and heavy oils and residue at the bottom. This separation occurs because each fraction has a different boiling point, allowing them to condense at specific temperatures and heights within the tower. This separation is purely physical, with no chemical changes yet, but these heavy fractions require further processing to become useful products. The initial distillation simply sorts the crude oil into broad categories based on their molecular weights and boiling points. Next, conversion units transform these heavy molecules into lighter, more valuable ones through processes like cracking, reforming, and coking. These chemical transformations are vital for maximizing the yield of high-demand products like gasoline and diesel from the heavier, less useful fractions. Cracking breaks large hydrocarbon chains into smaller ones using heat or catalysts, producing gasoline and diesel. Thermal cracking uses high temperatures, around 850 to 900 degrees Celsius, while catalytic cracking employs catalysts to achieve this breakdown more efficiently, yielding lighter alkanes. Reforming restructures molecules to improve the octane number for petrol, while coking heats residues to create petroleum coke and gas. Reforming specifically rearranges naphtha molecules into more desirable gasoline components, and coking converts heavy residues into solid petroleum coke and valuable gaseous byproducts. After conversion, the fractions must be purified. Treating units remove impurities like sulfur using hydrogen, producing cleaner fuels that meet emission norms. This purification step is essential not only for environmental compliance, but also for the performance and longevity of engines. This hydrodesulfurization process is vital for environmental compliance, as sulfur compounds contribute to air pollution and acid rain. Additionally, gas treating processes further purify gaseous streams, ensuring all products meet stringent quality standards. Finally, blending units precisely mix different streams to produce the final petrol, diesel, jet fuel, and LPG products. Modern automotive fuel, for instance, can contain up to 15 different hydrocarbon streams, each carefully selected to meet specific performance and cost specifications. The finished products are then stored in massive tanks and transported through pipelines, ships, and tankers to fuel stations worldwide. These storage facilities, often called oil depots or tank farms, are crucial for managing supply and demand, allowing companies to store products and distribute them strategically. Every time you fill your car, you're using the result of hundreds of interconnected engineering processes refined to perfection. The midstream sector, encompassing transportation, storage, and marketing, ensures these products reach consumers efficiently, often through complex pipeline networks that use batching to transport different products sequentially. So that's how a crude oil refinery works, from black crude to clear fuel. If you found this video helpful, please like, subscribe, and share it with your engineering friends. Stay tuned for more deep dives into industrial engineering and technology.